Let's see this. The same problem I have taken, but we are going to see a new algorithm called as optimal page replacement algorithm. Okay, optimal page replacement algorithm. We have seen two algorithms already. One thing is LRU and FIFO. Now let's see what is meant by optimal page replacement algorithm and find out the number of page faults. See, coming to optimal page replacement algorithm, it is the best algorithm, okay, which means the number of page faults will be the least. You cannot find an algorithm which will have lesser number of page faults than optimal. Okay, optimal is the best page replacement algorithms considering the page faults. But there is a small disadvantage coming to optimal page replacement algorithm. We will see that later. Okay, first we will understand how this algorithm works. Let's start this. We will start with page number 4. So since we are using demand paging, it will cause one page fault and page number 4 will be placed in the RAM. Fine. Then page number 7 is referred, one page fault. Page number 6 is referred, one page fault. Now page number 1 is referred, right? Page number 1 is referred. Since we don't have any frames which is free, what we need to do is we need to go for page replacement. We need to replace one among these 3 pages. Now which page should we replace depends on optimal page replacement algorithm, right? We are using optimal page replacement algorithm. So what optimal page replacement algorithm says is, you look into the future. Okay, see, as of now we are trying to place this frame, right? Out of these pages, which page hasn't been referred in the near future? You replace that page, which means, see, page number 7 is referred next, right? Which means we need page number 7 in the near future, right? So don't take page number 7 from the RAM. Why? In case if I replace page number 7 with page number 1, what will happen is, next when I see page number 7, it will cause one more page fault, right? I don't want that. I need to have the number of page faults as lesser as possible. So since I know that I will be referring page number 7 in the near future, I should not touch page number 7, right? Similarly, after page number 7, I will be referring page number 6. So I am not going to touch page number 7 as well as page number 6. Now page number 4 is the page which has not been referred in the near future, right? Page number 7 and 6, see, this is what we are trying to place right now, and this is the page number 7 and 6 are referred in the near future, so they should not be touched. Page number 4 is the one which has not been referred in the near future, so we need to replace page number 4 with page number 1, right? I think you understood the idea why this algorithm is the best algorithm, because this algorithm is really looking into the future, right? It is looking into the future and taking and then we are actually preserving the page, or we are actually having the page which will be referred by CPU in the near future. So the number of page faults will be lesser, right? See, we are maintaining page number 7 and 6 over here. We are not replacing page number 7 or 6 with page number 1. The reason being, these pages are referred by CPU. Now in case if I would have replaced one among these 2 pages, it should have led to one more extra page fault, right? Since I have maintained these pages, the number of page faults got decreased. So this way we are trying to keep the number of page faults as lesser as possible by using optimal page replacement algorithm, and this is the best algorithm considering the page faults, which means you cannot find an algorithm which will have lesser number of page faults comparing to optimal page replacement algorithm. Fine. Anyway, let's see this. So we have placed page number 1. Fine. Now again CPU is referring page number 7, no page fault, because we have intentionally kept page number 7 inside the RAM. Page number 6, no page fault. Page number 1, no page fault. Now CPU is referring for page number 2, right? Page number 2 is not present in the RAM. So we should be replacing one among these pages, right? We should be replacing one among these 3 pages with page number 2. Now which page should we replace? Page number 7 and page number 2 are referred in the near future, right? So what I want to tell you is, page number 1 and 6 are not referred in the near future. Only page number 7 is referred, right, out of these 3 pages. So you should not touch page number 7. You can either replace page number 1 or page number 6. No issues, right? See, in case if I replace page number 1 with page number 2, or in case if I replace page number 6 with page number 2, it doesn't matter. Why? Because the number of page faults will remain the same. Either I replace this page or this page, the number, it will lead to only one page fault, right? So no issues, you can replace any page you want. So what I'm going to do here is I'm going to replace this page, I'm going to replace this page with page number 2, right? So again CPU refers page number 7. See, page number 7 is already present, so no page fault. CPU refers page number 2, page number 2 is already present, so again no page fault. So the number of page faults coming to optimal page replacement algorithm is 1, 2, 3, 4, 5, right? So number of page faults coming to optimal page replacement algorithm, the number of page faults is nothing but 5, right? Number of page faults is nothing but 5. And important point you need to notice here is optimal page replacement algorithm is the best page replacement algorithm considering the page faults, which means the number of page faults will be the least in optimal page replacement algorithm. Now optimal page replacement algorithm has one disadvantage as well. It has a big disadvantage. What disadvantage? See, what we were doing in optimal page replacement algorithm, in case if I wanted to replace one of the pages, I am looking into the future, right? I am looking into the future and deciding which is the page and I'm seeing which are the pages which has been referred in the near future, and I'm trying to preserve that in pages inside the RAM, right? I'm not going to take the pages out of the RAM because they will be referred in the near future, and I don't want to come across page faults when they are referred in the future, right? So ultimately I'm dealing with the future, right? But the problem here is we cannot predict the future, right? While I'm executing this page, I don't know which page will be referred in the future. I don't have this reference string, right? This reference string I will be knowing only after the execution. After the execution, I will come to know that, okay, CPU has referred page number 4 followed by page number 7 followed by page number 6 and all this. But while I'm executing this page or while I'm placing this page, I don't know which page will be referred in the future, right? We cannot predict the future. So this algorithm is not practically implementable because we cannot predict the future. We cannot tell the future, exactly tell the future. Obviously we can predict it, but we cannot tell the future perfectly. So optimal page replacement algorithm has an advantage that number of page faults is lesser. Number of page faults is the least. Number of page faults is very less. But it has the disadvantage that it is not practically implementable. Why it is not practically implementable? Because nobody can tell the future exactly, right? So number of page faults coming to optimal is 5. So obviously optimal will be the best algorithm considering the page faults, and that's the reason we got lesser number of page faults. Okay, fine.